Gemstones, precious metals and power, building blocks of civilization. But how are they created?
Our Earth is a master chef. She knows how to cook.
These gems are really forged in unimaginable conditions deep inside the planet.
How did metals shape our past?
I love steel. It's actually the backbone of our society.
And how will these gifts be used to build the tools of tomorrow?
Such a simple element has enabled all of the technology that's around us today. It is amazing that this came from the sand that exists in our desert.
We're going to launch this incredible telescope, and we're going to send it 1 million miles into space from the Earth to actually unlock the secrets of the universe. And it will all rely on 2 ounces of gold.
In this episode, we go behind the sparkle of gemstones.
When you look into a beautiful gemstone, you're seeing something quite miraculous.
What are the secrets to their beauty?
This is no magic trick. This is just chemistry.
And what scientific mysteries do they reveal?
These are the biggest questions you could answer about geology.
It's amazing the role that diamonds have played in understanding Earth as a whole.
Treasures of the Earth, right now on Nova. All around us, we see Earth's abundance. Spectacular mountains, Caribbean blue seas, and plentiful crops. But Earth's bounty is not just skin deep. Some of our most important resources are forged even deeper inside our planet. These are the minerals that help make our modern world and inspire us with their beauty. Gemstones, like diamond, ruby, and emerald. We guard these treasures and cherish them as symbols of our love. But they also hold secrets about the formation of Earth itself. Just off Central Park, along Manhattan's famous Fifth Avenue, America's premier jeweler, Tiffany, has been selling these treasures to some of the world's richest people from the Gilded Age to the heydays of Hollywood. The store even played a starring role in this famous 1961 movie, Breakfast at Tiffany's.
Tiffany's the quintessential jeweler for the world.
Melvin Kirtley, Tiffany's chief gemologist, says that last year, Tiffany sold more than $4 billion worth of jewelry.
Our goal is to really search for the ultimate, those unique, rare specimens. When you look into a beautiful gemstone, you're seeing something quite miraculous. It's arresting. Here we've got really the most beautiful emerald necklace with this magnificent 45-carat emerald. The color is just verdant green, and it's just got this incredible saturation to it. This is really, truly spectacular.
At Tiffany's workshop, top-quality gems are crafted into prized jewelry. One piece can take months to create.
That's when you get the beauty from the stone. That's when you get the life, the brilliance. That's the wow effect.
But the story of how these gems were created goes back billions of years. Forged in some of the most tortuous conditions found anywhere on Earth, how can such violence and intensity create such delicate beauty? Clues about the massive force required lie just off the coast of China. Here, geologist Long Chan searches for evidence in the ancient rocks.
It seems like the rocks are talking to me. And there's always a story to tell. Hiding beneath the tranquility and the peacefulness of the rocks is a story of violence and tremendous complexities.
It doesn't take long for Chan to find a layer of rock folded nearly in half by the forces that create earthquakes.
This rock layer used to be flat-lying and continuous. Now it's completely folded, forming a V shape. The same kind of violent forces gave Earth gemstones.
Every gemstone is forged by a unique geologic recipe of chemistry, heat, and intense pressure.
Our Earth is a master chef, setting the temperature and pressure just right, using the right ingredient. She knows how to cook various kinds of gemstones.
The most treasured of all gems are created hundreds of miles below the Earth's surface. It is here where extremely high pressures and hot temperatures turn one of Earth's most basic elements into exquisite hard crystals, diamonds. So what are diamonds made of? To discover the ingredients requires doing something horrifying for any gem lover: torching a perfectly good diamond, which is exactly what chemist Andreas Sella will do.
And we often hear that diamonds are forever. But when we put this guy into a really hot flame and drop him into liquid oxygen, it begins to sparkle. And look, the diamond is burning away. And as it burns, it gets smaller and smaller and smaller. Eventually, it disappears. It's gone. We can burn it away to nothing except carbon dioxide. And that's because diamonds are made of nothing more than carbon. So we've taken the hardest natural material and we've made it disappear. And yet this is no magic trick. This is just chemistry.
Carbon is one of Earth's most common elements, nature's building blocks. It is essential to all living things, plants, animals, even our bodies, and crucial to man-made structures throughout our modern world. Carbon's versatility can be seen in two things, both pure carbon, but completely different: diamonds and graphite, or ordinary pencil lead.
When you look at these two, the diamond and the tip of the pencil, it seems almost insane to imagine that they're made of the same substance, the same element, carbon. And yet what it comes down to is the way in which those carbons are linked together.
The way in which atoms link together is the essence of chemistry. In diamonds, one carbon atom bonds with 4 others. This is repeated to create a dense, cage-like crystal structure. But in pencil lead, carbon bonds with only 3 others, forming flat sheets that stack like a deck of cards.
The sheets lie on top of each other, but are not fully bonded. They can slide one past the other. And when we write with a pencil, what we're doing is we're peeling those sheets off, 1 or 2 at a time, leaving a little gray trail, a little bit like a snail.
So why do carbon atoms sometimes make 3 bonds, like in pencil lead, and at other times 4?
This is just an extraordinary thing. How can one of the softest materials, one of the hardest materials, both be formed of pure carbon?
Bob Hazen of the Deep Carbon Observatory says the difference between pencil lead and diamond can be explained by the environment where the bonds form.
If you have fairly low pressure, the atoms can spread out. They don't feel compressed or strained, and so you have a much more relaxed crystal structure.
Graphite, or pencil lead, forms in low pressure, like near Earth's surface. But diamonds only form hundreds of miles deep inside our planet, where the temperatures and pressures are extreme.
As soon as you get pressure, the atoms are forced together. They have to be more and more efficiently packed together. And so the thing about diamond is carbon atoms are incredibly efficiently packed together.
Those efficient bonds are the key to making these prized treasures. Recently, a remarkable diamond, the second largest gem-quality stone ever discovered, was found in Botswana, weighing in at an incredible 1,109 carats.
It's truly historical. this could be, the most incredible piece of a diamond ever cut.
The estimated value of the diamond is $70 million. That's a whole lot of money for a rock that is nothing more than efficiently organized carbon. The secret of that efficient organization of atoms lies deep within the architecture of the carbon atom itself. At the atom's center is a nucleus with 6 protons and neutrons. Surrounding the nucleus are an equal number of orbiting electrons, arranged in what are called shells. The innermost shell can hold only 2 electrons. The second shell can hold 8. But carbon's 6 electrons only fill up half of that outer shell, leaving the atom unstable.
Every atom wants to find a comfortable electron arrangement, a filled shell. Now, carbon is in a funny position. It's got 6 electrons. So it's 4 away from 2, it's 4 away from 10, it's in the middle. So carbon is never quite that happy. It's always kind of striving to find a different configuration.
The configuration when carbon is most happy is when its electron shells are filled, like in this diamond crystal. But there are many combinations that can fill carbon shells, and that's why it's such an important element in our natural world. It even plays a starring role at this glamorous Tiffany Gala. The movie star's hair is made of protein which is packed with carbon. Their flawless skin and high cheekbones have a lot of carbon too. And of course, under the extreme conditions deep inside Earth, carbon atoms bond into the exquisitely hard, exquisitely clear, and exquisitely expensive diamond. But it took a lot more than beauty for these diamonds to get to the red carpet. Diamonds are forced to Earth's surface in a very special kind of volcanic eruption. The rock inside traveled hundreds of miles through Earth's mantle at up to 30 miles an hour. The diamond just comes along for the ride. Raw diamond crystals can be seen still embedded in this rock, known as kimberlite.
The diamond was just an accidental passenger en route to the surface of the Earth.
These eruptions leave behind very deep funnels of kimberlite and diamond, which is why mining diamonds takes a severe toll on the landscape, and at times an even bigger toll on humans. In places like Sierra Leone, Africa, uncontrolled mining has led to horrific conditions for the miners. The diamonds they find can head straight for a black market that have funded warlords and weapons in brutal civil wars. These are the so-called blood diamonds. Diamonds that are legally exported are subject to strict controls and sent to just a handful of diamond centers worldwide. 90% of America's diamonds pass through one city, New York, famous for its hustle-bustle and bling. This is 47th Street, the Diamond District, where trader Ronnie Vanderlinden is one of its many unofficial mayors.
Welcome to 47th Street, the land of everything. But what this street is really known for, what it's about, is its magnificent diamonds. I like the shizzle. I like it all.
Today, he has a little business with Gregory Jazarian.
Gregory.
Hey, Ronnie, how are you?
How are you, buddy?
That's great. Do you have those stones?
I do.
Negotiating the sale of a $250,000 square-shaped diamond.
I think this might be the winner.
A key step to make a diamond worth that kind of money is the cut, which reveals the sparkling beauty of the stone. Michael Kaufman is a master diamond cutter.
I've been in the business since 1966. I started off as an apprentice diamond cutter. I was a baby, literally a baby.
Today, he's repairing a chipped diamond. While diamonds are the hardest material on Earth, they aren't very tough. Which means if you strike it at just the right angle, between the planes of carbon atoms, it will break. This line of weakness is called the cleavage grain.
I'm going to look for the grain of the stone. People don't realize that diamond has grain just like wood has grain. If you take this entire building and put it on top of this diamond in the street, it will make a hole in the street. But yet, if you hit it on the cleaving grain, it will take off a small piece, sometimes not so small.
That grain is also key to transforming the rough rock into a shimmering, faceted gem.
When the job is done and all the facets are where they should be, and I see the brilliance, I see that stone talk to me. And it says, Michael, did a good job.
Revealing a diamond's beauty comes down to the careful arrangement of these facets.
Diamonds need to be cut in very, very specific parameters to get it to maximize light return.
This is the round brilliant cut, one of the most popular shapes in the world.
When a diamond is proportioned in a perfect way, it will act as a hall of mirrors. If it's not, then the light will push out of the back and you'll basically lose light.
In 1919, a Belgian mathematician named Marcel Tolkowski used principles of optical physics and math to determine the optimum number and angle of facets to create a diamond that perfectly caught the light.
When he came along, it was more putting a science to the actual proportions and understanding that they matter.
Imagine this is an uncut crystal with a smooth surface on it. And now we're going to shine green light onto it.
Debbie Berabishe, a physicist, explains how light can be captured in a crystal by using a green laser, so our camera can see it.
So we see that spot on the wall because most of the light is getting transmitted to the other side. Now, if instead we used a faceted crystal, we can see how most of the light is getting trapped and bouncing around inside the crystal. And a lot of it is coming back, reflected into our eyes, very much like a hall of mirrors.
Tolkowski found that a diamond cut with nearly 60 carefully angled facets created an exquisite geometry that reflected light around the stone many times, then bounced it out through the top and into our eyes. We call this phenomenon brilliance. When white light enters a diamond at just the right angle, something extraordinary happens. These facets, along with how the diamond affects wavelengths of light, disperse it into a rainbow of colors, like light through a prism. This creates the flashes of color called fire.
Because of diamond's hardness, the polishing of the facets creates such incredible mirrors that the diamond bounces the light back to the eye. So you're really getting a combination of light to give this beautiful dispersion and sparkle.
It turns out that a diamond's brilliant sparkle comes down to optical physics, something truly to sing about.
But square cut or pear shape, these rocks don't lose their shape. Diamonds are a girl's best friend.
As Marilyn Monroe did in this 1953 classic,
Tiffany's,
Gentlemen Prefer Blondes.
Cartier.
In Washington, D.C., there is a very special diamond that Marilyn Monroe would surely have loved to get her hands on. 6 a.m. Inside the Smithsonian's Museum of Natural History, the Gem Gallery is on lockdown. Curator of gems Jeffrey Post is removing the museum's most infamous and most visited exhibit from its bulletproof case.
What I'm holding right now is probably the world's most famous diamond. This is the Hope Diamond. It is a large blue diamond, 45.5 carats, the largest, finest blue diamond that we know of anywhere in the world.
Post says it is impossible to estimate the diamond's value, in part because of its long history of intrigue. It was bought in the 17th century by Jean-Baptiste Tavernier and sold to King Louis XIV of France. It is believed that during the French Revolution, the diamond was smuggled to London, recut, then purchased by the Hope family where it got its name. But only after it was sold to the American socialite Evelyn Walsh McLean, whose family was soon struck by a series of tragedies, did the diamond earn its famed reputation of being cursed. So finally, this legendary and mysterious diamond was purchased by the jeweler Harry Winston and given to the Smithsonian Institution. There is, of course, no scientific way to shed light on the diamond's alleged curse, but there is definitely science behind its magical blue color. And today, Jeffrey Post wants to reveal the secret. The precious diamond is put into a mass spectrometer, where a laser is used to break free individual atoms that then travel through the machine. A clear diamond is pure carbon, so all the atoms would travel at the same speed. But today, the machine detects a few atoms flying faster. This means there is an impurity in the diamond.
Boron, yeah, right here.
Traces of a lighter element called boron.
On average, our measurements reveal that the Hope Diamond has about 1/2 part per million of boron. And it's the tiny little bit that is just enough to make a colorless diamond the deep, dark blue color that we know as the Hope Diamond.
But boron isn't blue, so why does this impurity change the color? It results from how different atoms handle light. The carbon atoms in a diamond are bound together by their electrons, but these electrons can also interact with light when it shines into the gem. In clear diamond crystals, since all the electrons are bound together, all the colors in white light pass through. In the Hope Diamond, an atom of boron replaces a carbon atom, but boron can only make 3 bonds, not 4. That changes the electronic structure of the diamond. When white light hits this atom, it absorbs some of the wavelengths of red light. But the blue light passes right through, making the Hope Diamond appear its unique color of blue.
The Hope Diamond is one of the most unique objects in the world. Look at how many other blue diamonds comparable to the Hope Diamond have been found, and the answer is 0.
There may not be another diamond quite like the Hope, but gems can come in a surprising array of colors. We all know emeralds are green, rubies red, and sapphires blue. Well, frankly, that's just plain wrong.
Is this a sapphire? This is blue. It looks like a sapphire. It's nice and big, but it's not sapphire. You can't go by color.
In fact, none of these green stones are emeralds. Yet surprisingly, all of these are what we call sapphires. Color is something that Mike Scott is passionate about and wants to understand in everything from brilliant gemstones to the koi fish he keeps in his backyard.
Color brings out all kinds of emotion, just like smells do. I enjoy the complexity or understanding how things work. To me, color sets what mood I'm in.
Scott has amassed what is considered one of the world's most important collections of gems outside of a royal family.
Mike Scott is one of the world's great connoisseurs of gems. He goes out of his way to find the most beautiful colored stones. And each of those colored stones is telling us a story.
Part of my collection is just show there's more to the world than sapphire, ruby, and emerald.
Scott may not have a diamond quite like the Hope, but he has collected diamonds in almost every known color, including yellow, green, pink, and even the rarest, red. Scott's rainbow collection was made possible by Apple Computers. He made his fortune as the first CEO, taking it from Steve Jobs' garage to going public on Wall Street.
I hand-built the first 10 Apple IIs.
But Scott says his first task at Apple came not from Steve Jobs, but the other employees at the time.
My first job as president of Apple was to tell Steve Jobs he had to take a bath.
It seems that Steve's special diet was creating body odor.
He negotiates everything, so he agreed to take a bath more often, and I had to agree to read his diet book, hopefully that it would cause me to lose some weight, which it didn't.
Scott didn't plan on investing his fortune in gemstones, but he got hooked the first time he tried to buy himself an expensive one, because it turned out to be a fake.
That got me further interested in how do you know the difference, since you can't just tell by color and by looking at a stone.
A physicist by training, Scott wants to better understand the nature of minerals, materials that are crystalline in structure and include gemstones. Scott is so devoted to this pursuit that he has removed all the traditional furniture from his Silicon Valley living room and turned it into a world-class gem and mineral lab. Out with the couch, in with the Raman spectrometer.
Mike Scott has put part of his fortune into building the world's largest database of minerals, their structures, their properties, their optical characteristics, so we understand this rich realm, the kingdom of minerals, in much more complexity and completeness than we ever have before.
Today, Scott is analyzing a sapphire, a 30-carat one.
This one's from Sri Lanka.
Like the Hope Diamond, it's blue, but how it got its color is a completely different geologic story. Sapphires are actually more rare than diamonds. Making one requires the force of moving mountains, literally. Sapphires are formed in Earth's crust, not the deeper mantle where diamonds form, during the geologic process of plate tectonics. All the continents on Earth ride on giant tectonic plates, pushed and pulled by heat deep within the Earth. For likely billions of years, the continents have moved around, crashing over and under each other, causing earthquakes and pushing up huge mountains. Beneath Earth's surface, heat and pressure created from the massive friction liquefy rock that reforms into new minerals, sometimes sapphires. Many of the best sapphires come from the island nation of Sri Lanka, off the coast of India, which was caught in the middle of colliding plates 600 million years ago. Gemologist Andy Lucas is on the hunt for these precious stones, a task that requires going down in a traditional pit mine.
Hi. Can I take a look? Thank you, sir.
Entering the mine, Lucas finds himself in a wet, potentially dangerous environment.
Now you can see the wooden braces, you can see the struts supporting them. Now they have a problem here with groundwater, so they can't go too deep. And they have to be careful for the eruption, so they don't have a tunnel cave-in.
What they are mining is a loose gravel called elam.
Then they'll take this metal bar, pointed metal bar, and they'll dig it into the elam. Then they put it in bags.
The bags are hoisted up on ropes. Andy's route back up the slippery bamboo scaffold is a bit tougher. Once on the surface again, Andy examines the gravel elam.
It's gonna look like a lot of mud, but also with some pebbles in there. Now, I'm not seeing any gemstones yet, but after washing bag after bag after bag of this muddy gravel, then they might find something, maybe something that can change their lives.
The elam is sediment, comprised of rocks and dirt that washed here from upstream.
Nature kind of did a bit of the work and concentrated them in an area.
If a miner is lucky enough to find a gemstone in this loose elam, it is sent to the city to be polished into true treasures. Armil Samun and his family specialize in polishing and cutting sapphires.
My family has been in the business for 5 generations. It comes into your blood and then it stays there.
It's the beauty of the stone.
It's just beautiful. You can just sit for hours just drooling over it.
Today, they're at work trying to figure out how to cut a 90-carat rough sapphire. A finished gem jumps in value when it hits a larger threshold, like 10, 20, or 50 carats.
It's almost a perfect crystal.
Samoon's goal is to cut this down to a well-faceted 50-carat gem, but that will take careful planning.
We can sit on it for 2 weeks, 10 days, just, fool around with it, think what's best.
Come back, take a look, have a cup of tea, and then think about it.
Make the wrong decision, and it could be a costly mistake. One of the world's most celebrated gems is the 12-carat sapphire from Sri Lanka that was worn as an engagement ring by Lady Diana. Today, the same ring is worn by the new Duchess of Cambridge. This brilliant blue sapphire is estimated to be worth $400,000. But in the bustling Sri Lankan market, the sapphires that Lucas discovers are not what you might expect.
This stone has very little color in it. Not quite colorless, but almost. Believe it or not, this is a sapphire.
Sapphires are a variety of the mineral corundum, which in its pure state is colorless. Corundum crystals are made up of aluminum and oxygen atoms. It is the second hardest natural gemstone after diamond. But colorless corundum is not a treasure. Its value comes from its impurity.
What gives corundum its color is what we call trace elements. In the case of blue sapphire, it's iron and titanium.
Different impurities absorb and reflect different colors of light, similar to the Hope diamond.
Take a look at the color. Would you believe me if I told you this is a sapphire? This stone is purple, and it's still a sapphire.
Sapphires come in yellow, pink, and of course blue. But one color of sapphire has a name all its own: ruby.
I think most people don't realize ruby and sapphire, they're related. They're both from the mineral corundum. They're varieties. It's just a color distinction that we give these gems their famous names.
Ruby's color comes from the element chromium. Their rarity makes them one of the most valuable gems. Sapphires and rubies show how even Earth's imperfect recipes can lead to some of its most beautiful creations. Cooked by the heat and pressure of colliding tectonic plates, impurities can turn a simple, dull rock into a rainbow of rare and precious gemstones. But not all gems are found washed loose. Emeralds are some of the rarest gems, but hunting for them requires patience and explosive power. Jamie Hill and Ed Spear of North Carolina have been mining emeralds for more than 30 years.
Almost 10% of all of the emeralds found on this property are greater than 100 carats. That means they're that big or bigger. These are some of the biggest, best emeralds in the world.
Emeralds are formed by the hot, mineral-rich fluids generated when land masses collide, as they did about 380 million years ago here in what is now North Carolina. The challenge for Jamie and Ed is that these emeralds can be anywhere here, still encased in the rock where they formed.
That's a nice specimen.
That's where the firepower comes in.
We have got over 3,500 pounds of high explosives. And it's going to be over 10,000 tons of rock. This is going to be a big one. I mean, a real big one.
Blowing up a lot of earth is all in a day's work for Ed and Jamie. But today, like most, they come up short. The explosion didn't reveal any obvious new emeralds.
So we've got several days of hard work here, but I'm very excited because emeralds could be anywhere at any moment. Oh.
There's the big one.
Remember that one? Remember that one?
Ever. It's that big one that you found at the end of the day.
You were about to go home.
I wanted to go home. I was tired.
I'll never forget that. That emerald weighs over 1,450 carats.
Making it one of the 10 largest emeralds ever found in North America.
And this is only one of the treasures Jamie and Ed have found. To date, they have uncovered $9 million worth of emeralds and have no plans to stop looking. But if two men at one location can uncover that many, it begs the question, are precious gems like diamonds and emeralds really that rare?
It's so funny to think about the marketing of diamonds, making them sound incredibly rare and incredibly valuable. And of course, a big, perfect diamond is a rare object. But the typical diamonds, half a carat, 1 carat diamond, they're available by the billions. And they have to be, because otherwise you wouldn't have a jewelry market.
Robert Hazen believes that the value of gemstones is largely a creation by the jewelry industry, not nature. But in some cases, the value comes from traditions, thousands of years old. Nowhere is that more evident than in modern Beijing. Here, despite the onslaught of rising wealth and luxury goods, there is one ancient treasure that rises above all others: jade. In China, jade can be even more valuable than diamonds.
This jade necklace is called Water's Love. It is made up of the highest quality stones, perfect for attending galas. It will elevate the party-going lady's status instantly. Whoever wears Water's Love, she will be the queen of the party.
Lisa Dong sells jade pieces that can cost upwards of $20 million. Even traditional jade bracelets, which have been worn by women here for thousands of years, can easily cost tens of thousands.
When you click two jade pieces together, the clicking sound represents a character trait, a refusal to be contaminated by evil influences.
Jade bracelets are thought to bring luck and happiness with no end or beginning, just like their shape.
When a Chinese woman marries, diamonds are not important. What is important is to have a jade bracelet and ring. They embody the ideas of Confucius: benevolence, righteousness, courtesy, wisdom, and trust.
How can one stone mean so much to so many? There is no better place to find an answer than in the heart of Imperial China, the Forbidden City. Lin Shu is a specialist in ancient jade.
Westerners may believe jade is a normal stone, but in the eyes of us Chinese, jade is not only a beautiful stone. We have such a long history of jade objects in China. From its initial use of connecting us to the gods, we add more functions to it throughout the years. And now, the culture of jade coincides with Chinese culture and history.
Over China's very long history, jade became increasingly connected with the imperial ruler.
Jade's association with the emperor developed in stages. Owning jade was forbidden to common people. They could lose their heads if they were caught using jade. There were strict rules.
Some of the most important pieces of jade were the emperor's seals, called shi.
All of the 25 shi were equally important, tightly connected to the emperor's rule and lawmaking. This is a green jade shi for signing important documents that make announcement to the entire nation. Whoever owned the shi was to own the entire country. Ever since then, every dynasty carried on the tradition. Dynasties fought over the control of the shi.
The English word for jade describes what are actually two completely different minerals: jadeite and nephrite.
In my left hand is a mineral called jadeite. In my right hand is a greenish mineral called nephrite. Both are, generally speaking, referred to as jade. But chemically, these are two very different minerals. One way you can tell between a jadeite and a nephrite is to rub one against the other. And you can see that the jadeite, being slightly harder, can scratch the nephrite.
Nephrite has the much longer history in Chinese culture. One massive piece of nephrite jade that was prized above all others by the emperor still sits in the Forbidden City.
Altogether, this sculpture took 10 years to complete. It is also the largest jade sculpture in China.
That tradition of intricate carving still continues in the town of Yangzhou, north of Shanghai. Jade is not chipped away like marble. Historically, pedal-powered machines and a hard abrasive were used to slowly grind and shape the stone. Even today, with the help of modern tools, jade requires patience to slowly reveal the beauty of the stone. Master carver Yi Jinggao says it is unlike diamond, which is clean. You can't cut jade. The first step is to remove the unnecessary parts. The second step is grinding slowly for the piece to take shape. The earliest uses of jade were as primitive tools, because the toughness and durability of the stone allowed it to be shaped into useful forms. Richard Vinci is a materials scientist at Lehigh University.
Mostly we associate toughness or being damage tolerant with metals. With a lot of minerals, as soon as they start to crack, they just come apart. Jade is a little bit different, and it comes down to the internal structure. Not down at the atomic scale, but at the micrometer scale.
Oh, that's looking more promising. Maybe if we were to come into this area over here.
This piece of jade has all of these little crystal fibers that are long and skinny. They look almost like little noodles of spaghetti, and they're all packed together tightly to make the solid crystal. In this area, the fibers are all running this way, but in this area, looks like they're running across this way. Down here, they're running at sort of a diagonal. So as you try to crack it, the crack may go through one bundle, following the fibers, but as soon as it hits the next bundle where the fibers are oriented in a different direction, it has a very difficult time, and that gives it a fair degree of toughness.
That toughness has led to another belief, widespread in China, that jade protects the person who wears it. One reason so many people buy jade jewelry.
Chinese people normally believe jade carries a blessing. We've all heard many stories that a piece of jade shatters in order to protect his master.
I think it's often the case that people associate physical characteristics with more moral or mystical characteristics. So the characteristics that we associate with that material are coming from its individual atoms and their electron structure and how those atoms are arranged. We really can't appreciate that at the level at which we're using it, but we certainly appreciate the properties that result from it.
There is another gem with unusual microscopic properties that some call the Queen, and it is mostly found down under. Australia has 95% of the world's precious opal. Black opal is the most rare, and famously comes from one town, Lightning Ridge. Anthony Malonis is a fourth-generation miner.
It's in my blood. I look at diamonds and emeralds and rubies and sapphires. Well, opal's the queen. Opal is the queen of all the gems.
Malonis says the only way to find an opal is to carefully dig away at the outback's clay walls.
The thing about opal, just when you think you know what you're doing, it'll surprise you. It can form anywhere. And what you don't want is this piece of machinery going right through a big opal.
Fortunately, in the white rock, The colors of opal make it relatively easy to spot. These vivid colors are what gives the stone its value. Opal can come in many colors, including deep blue-greens, intense purple, or fiery red, and it has a sparkle all its own, again a result of its microscopic structure.
I love opals. Not only are they very flashy, but they're also very different from most of the other gemstones. And instead of irregular little crystals, they're these perfect little spheres.
An opal is made up of tiny spheres of silica, a mixture of silicon and oxygen found in sand and even ordinary window glass. The spheres are so small that when packed together, they can scatter wavelengths of light, creating flashes of different colors.
And so, depending on the size of the spheres, you will get different colors appearing. Certain opals will flash mostly green or mostly red, or maybe a mixture of these colors.
Opal is not a crystal, like most other gems. It is a collection of billions of glassy spheres packed together and surrounded by a small amount of water. Just how opals formed is not completely understood. One interpretation is that under rare conditions, water percolated through the ground and dissolved silica from rock. That viscous mineral mix filled in cracks in the earth and slowly solidified, like jello in a mold. Opal can form in any gap, or even fill in fossils left by ancient life. These rare fossils are a colorful record of a prehistoric world, preserved in part by a unique geology in Australia where very little happened. All evidence of an exquisite connection between geology, life, and precious gems. The beauty of every gem comes from a unique recipe inside Earth. But can they tell us something more? Are there clues held by these gems that can solve some of the most enduring mysteries in the field of geology? One of those mysteries is when the important process of plate tectonics began. Giant tectonic plates, pushed and pulled by the need to release heat deep within Earth, have shaped the map of the continents into what we know today, and made Earth more geologically active than all other known planets. But when did this critical process begin?
When plate tectonics begins is a huge question. Some people think it's more than 4 billion years ago. Some people think it didn't really get started until less than 1 billion years. That's a huge discrepancy. So any insight we have on how plate tectonics began is incredibly valuable to understanding our dynamic planet.
Stephen Shirey at the Carnegie Institution for Science thinks these diamonds may hold the answer, literally.
So we're looking at 3 rough diamonds. Rough diamonds means uncut.
Shirey, a geochemist, is investigating what others consider bad diamonds, ones with flaws, tiny bits of earth trapped inside called inclusions.
Here's one here, here's another one. These black specks would make this diamond not good for the jewelry market. So Tiffany's would not like this particular specimen.
Tiffany's may not want them, but for Shirey, these diamonds are, in effect, an ancient safety deposit box, preserving the chemistry of early Earth.
Diamonds are the best container you could have for anything. When they enclose a mineral, they become the best time capsules we have.
The first step is getting to the flaw. After all, this container is made of the hardest material on Earth.
What we have here is a diamond cutting laser. It's going to cut from top to bottom, and that part of the diamond will be actually vaporized. All right, Joe, let's go ahead and cut this baby, all right? Here we go, ready? When I see a diamond, like anybody, I love its beauty, but I really love a diamond that has a lot of flaws.
Then the diamonds are polished to clearly reveal the inclusions.
Then we can get a really good look at the inclusions. You can see 1, 2, 3, 4.
By breaking through the diamond and analyzing the chemistry of the minerals, Shirey has found something startling. Minerals billions of years old that could only have formed on the surface. But given that diamonds form deep within the Earth, how did that happen? Shirey believes that the motion of plate tectonics carried the minerals deep into Earth, where the material was encapsulated by a diamond.
So that's a dead ringer for the idea that they're from the surface of the Earth.
But Shirey has never found surface minerals in a diamond older than 3.2 billion years. And that suggests that plate tectonics, or a related process, could have begun at about that time.
We can take very tiny grains and scale up to very large questions. And these are the biggest questions you could answer about geology on the Earth. And we're doing it with almost the smallest specimens that the human can study.
You know, it's amazing the role that diamonds have played in understanding Earth as a whole. Diamonds give us hints about how Earth works and how it was made.
The journey of gemstones, both flawed and flawless, reveal forces of Earth's unimaginable power, as well as the heights of artistic and scientific endeavor. Around the world, that process continues today, as scientists are finding new uses for these ancient treasures. Lasers that employ the clear optics of rubies, and diamonds' thermal conductivity used in the next generation of quantum computing. So whether under museum guard, for sale at Tiffany, or in laboratories around the world, these treasures prove that their value, both aesthetic and scientific, can indeed last forever.